Welcome to the Cosmic Savannah with Dr. Daniel Cunnama
and Dr. Jacinta Hayes. Each episode, we'll be giving you a behind-the-scenes look at world-class astronomy and astrophysics happening under African skies.
Let us introduce you to the people involved, the technology we use, the exciting work we do, and the fascinating discoveries we make.
Sit back and relax as we take you on a safari through the skies.
Welcome to episode 58.
Welcome to our season 4 finale.
So, as is our tradition, we will be taking a little bit of a break over the next couple of months, and we will give a little review of the past season, the past 10 or 15 episodes, some of our favorites, some of the highlights, and looking forward to the future.
Yeah, exactly. And so it's a review of the season, which we all know doesn't really mean anything on the Cosmic Savannah. It's just arbitrarily when Dan and I choose to start it and end it. But I think we covered about, somewhere between 17 and 20 episodes, I think, this season. It was a hefty one.
We did have a good long run. But I think we've got a well-deserved break.
Yes, we started on August 2nd, 2021, which was nearly a year ago, and incidentally, is only slightly longer than the amount of time I've been in Australia for.
Sure, that's gone quickly. Man, feels like just the other day.
Does it? I feel like I've been here for ages.
I think I've lost all track of time. Yeah.
Yes, time is travelling at a strange rate. But anyway, so this was a transcontinental season.
We've been doing some very long baseline podcasting for the last year, and not without its difficulties, but I think we've managed to succeed pretty well. I look forward to hopefully having you back for the next season, then we can hop into the studio and get some good quality recordings to Jacob.
Oh, yes, our long-suffering editor, absolute superstar, has had to splice together recordings from different microphones, starting at different times, ending at different times. We were an absolute nightmare. So thank you, Jacob, for putting up with us.
Not to mention some terrible Zoom recordings, but
and some terrible jokes that he's cut out for us.
If you're looking for those terrible jokes, they're generally at the end.
Yes, a lot of them end up as bloopers. So anyway, yes, as our tradition is, we're going to do kind of like a review of the season. And, well, how should we start, Dan?
Perhaps some of the biggest episodes or some of the highlights from the past year?
Yeah, okay, the milestones from the previous 12 months. In the world of astronomy, well, first of all, the SKA received the green light to go for construction, which is enormous. We covered that in our very first episode of the season, episode 37, with Professor Phil Diamond, who is the Director General of the SKA.
A great interview, great to hear from Phil, and some very exciting times ahead. So I think since then, construction has begun. There's been contracts awarded, infrastructure is going in both Australia and South Africa, and we will hopefully be having some telescopes coming along in the next couple of years.
Have we had the groundbreaking ceremony yet? I don't think that's happened just yet.
No, that hasn't. I'm not sure whether it was supposed to happen yet, or whether that's whether that's a COVID delay, or whether that's they're waiting for the site to be ready for maybe the first telescope. But no, there hasn't been a ceremony, or I didn't get invited to it.
Yeah, I was going to say, I hope there hasn't been, because I would be very offended if we didn't get to go.
So hopefully the former. Another amazing and very exciting telescope was the James Webb Space Telescope, which was launched on Christmas Day last year. Very exciting for everyone, mostly for my family who didn't get to celebrate Christmas, but rather the launch of a telescope.
Yeah, I forced my mum on Christmas night to sit in front of the TV and watch the launch. She was a good sport, but she didn't quite have the same enthusiasm as I did when it launched and didn't blow up.
Yeah, we spoke with Professor Christy Tremonti in episode 45 all about the James Webb Space Telescope, what incredible science it's going to achieve over the coming years. And, since we spoke, the telescope has been launched. It's been taken out to its Lagrangian point where it's sitting comfortably, and it's opened up like the butterfly that it's supposed to. Everything seems to be working really well. And it was recently announced that on the 12th of July, they will be releasing the first images.
Ooh, that's exciting. And I heard that it was hit by a micrometeorite.
Yes, yeah, I saw that too. I think it was hit by a couple, but one of them was fairly big. So the mirrors have got a couple of pockmarks in it already, which can't feel very good. But I think that's the nature of spinning around in space.
Oh, those instrumentational instrument. What's the word I'm trying to looking
Instrument
for?
scientists, let's go for that.
Okay, the instrument scientists and the engineers who spent so many hours, weeks of their life, like making sure those mirrors were perfect to within microns and smooth, and then it gets hit by a micrometeorite. Apparently did quite a bit of damage, but that it's okay, that it won't affect the image quality.
Yeah, I don't think it's how, we think of a mirror breaking. It didn't shatter onto the floor, but it just has a little tiny pockmark in it. I think these micrometeorites are incredibly small. Apparently, yes, no degradation of the science, or very very slight. So nothing really to worry about. But let's hope that we don't get a bigger one.
Yeah, yeah, exactly. I guess it was probably one of the bigger dust particles that Amima was talking to us about on our previous episode 57, From Dust to Dust. Maybe it's some of that pesky dust has now hurt our precious JWST. But yes, coming up in our next season, we will be sure to, in one of our first episodes, discuss the first images coming from JWST, and I cannot wait.
No, very exciting indeed.
And of course, who could forget the recent announcement from the EHT, the Event Horizon Telescope, where they finally imaged finally. I mean, I say like, oh gosh, guys, how
About
late
time,
it's such
guys.
a delay.
Come on, yeah.
About time, yeah, no. They finally released the image of our own supermassive black hole, Sagittarius A star, at the center of the Milky Way. Chatted about that with Dr. Inyan Natarajan in episode 56.
The black hole at the center of our galaxy is something that we are looking at like straight through the galaxy, and that makes it more difficult to image. And also, it's a much smaller black hole than the other one that was imaged in 2019, which also means it's rotating faster, which means you needed to develop new algorithms and new software to actually be able to handle that. And which is why it took almost 5 years since the collection of the data to come out with this image in 2022. And it's exciting because it's our own black hole at the center of the galaxy that we live in.
Yeah, another amazing achievement, and I think we did speak to Inyan a little bit about that and what is coming next for the EHT. Obviously, they are continuing to add other telescopes, potentially the African Millimeter Telescope, which is planning to get built in Namibia in the next few years. So that'll be a very exciting aspect from Africa's perspective, and increase the quality and the capabilities of that Event Horizon Telescope, so we can try and get some better pictures of M87 and Sagittarius A star, and learn more about our supermassive black hole. And who knows what else?
Yes.
Yes, that's why we do it. Who knows what else?
Yeah, so cool. Okay, so what was your favorite episode of the season, Dan?
I know what yours is, and maybe we should start with that.
Why? Are you going to say the same one as me?
I am, I think.
All right, say it. Say what yours is.
Yeah, I mean, I know you fangirled so hard when we spoke to Bernie. I mean, it was an incredible episode. I think, an amazing interview with an amazing human being, and just what he's achieved in his lifetime and what he's achieved for South African astronomy, and global astronomy, in particular radio astronomy. It's, all the awards which have been bestowed upon him are well deserved. I think that the impact that Bernie Fanaroff has made on astronomy cannot be understated.
Yeah, of course. So that's Dr. Bernie Fanaroff, who we spoke to for our very special 50th episode. And we heard so many amazing stories from Bernie. But I think my most favourite was when he told us the story of how he had no idea he was famous in the astronomy world. He had no idea that there was a radio galaxy classification system named after him, the Fanaroff-Riley classification system. So that was super amazing to hear that story.
He'd spent 30 years, blissfully ignorant of the fact that he was famous and presumed dead within the radio astronomy
Yeah, presumed dead. Gosh.
So let that be a lesson to young astronomers.
How does it feel to have something named after you?
Well, it was a bit surprising, actually, because in 1976 I left academia and left astronomy. And soon after I joined the project, we went to a meeting of the SK consortium, and one or two people said to me, "Are you the Fanroff Riley?" And this was actually news to me. And they said, "We thought you were dead because nobody's heard anything of you since, 1974. So I said, "No, I haven't died, and it is me." But it was all a bit of a surprise.
If you don't keep publishing, everyone thinks you're dead.
Oh gosh. Don't take that as a lesson, young astronomers. No. That's taking publish or perish to a whole new level.
Very nice.
We had a lot of amazing science results coming out in the astronomy community within Africa, within South Africa in particular, and some results from the SALT telescope, so from the Sutherland Plateau.
Yeah, I think that, as Bernie said in his interview with us, that science isn't done by telescopes, it's done by people. And we've chatted to some wonderful people through the season, some of them about the exciting things which are happening at the South African Astronomical Observatory with the Southern African Large Telescope SALT, and also the new Atlas telescope, which is in collaboration with NASA and the University of Hawaii. So yes, we spoke to Elizabeth Naluminza, who is a new SALT astronomer here at SAO, and she is operating this massive telescope now. And we spoke a little bit about what SALT does, how it works, and Elizabeth told us about some of her work and where it's going. There's definitely been some exciting developments in SALT. There's a new instrument which arrived a couple of weeks ago. It's currently sitting up in Sutherland, about to get boxed up inside the big... There's a massive room there which is cooled and wrapped in polystyrene and whatever else, so that you can never see any of the instruments. Before it does, a couple of people have shot up to Sutherland to try and see that before it gets locked up for good.
Oh, really? Cool.
Yeah, there's a near-infrared spectrometer which has just arrived and will greatly increase SALT's capabilities. So we'll speak about that more in the next season of the Cosmic Savannah. No, we didn't.
Cool.
Just imagine you have, the birthday cones that we wear on the heads for kids' birthdays?
Oh, like the party hat.
Yes, the party hats. So imagine the party hats, and you've stacked several of them on top of each other. So what you have is conical surfaces of constant wavelength.
Okay.
And the software to unravel these and to help determine the wavelengths at different points in the images. That's what I'm working on.
Wait, what is it that is boxed up?
So all of the instruments are cooled. So they get put in this big room, and inside the room, which is cooled, there is like the biggest cooler box that you've ever seen. And then inside that, there's like another cooler box. And then inside that are the instruments. So if you actually are interested in the instrumentation and you want to see the fibers coming in and the lasers going and whatever else, you can't. It's getting installed now, but once it's installed, it gets sealed into this box to be cooled. And unless something needs to be upgraded or changed, all you can see is the outside of a cooler box. So astronomers being astronomers and scientists being scientists, everyone wants to see it. I want to see this thing with my bare hands before I...
You want to see it with your bare hands?
Exactly.
Yeah, okay. Double down on that one.
Yeah. Don't actually, see it with your own eyes, because don't touch it with your bare hands.
No, I was going to say, don't touch it. You'll get in big trouble. I'm actually one of those rare, well, I don't know if it's rare, but I'm one of those people who just has absolutely no interest in seeing the actual physical thing. I'm so boring in that sense, but I just I don't care. It's so awful.
I saw one of our new lasers the other day. I was also like, I don't know. Do I need to see a laser? But then, you see the laser and it comes with a little piece of cardboard in different colors so that you can just check that it's shining in the correct wavelengths. And then you look at the piece of cardboard and you're like, well, why is the piece of cardboard so damaged? Oh, no, because if you leave the laser there for too long, then it just burns a hole through it. Okay, cool.
Okay.
So, cool. Don't stick your hand in that.
Well, Well, speaking of lasers, that's an excellent segue to the space laser.
Yes.
The space lasers we talked about in episode 53, where Dr. Marcin Głowacki told us all about this. Well, it's called a mega maser, an OH mega maser, which they nicknamed... I still can't say the name. Dan, can you help me out here?
Ngalagata.
Kalagata, okay, which means big boss, right?
Big boss, yeah.
Yeah, in
Zulu.
Zulu, right.
So this sort of emission in hydroxyl is known as masing.
So this is a space laser, but with an M.
Yes, in this case, we're looking at a galaxy which had just undergone a recent merger. So two galaxies have collided and formed a bigger galaxy. And this will make a lot of dense gas within the host galaxy. And this amount of gas, hydroxyl molecules, is so bright that we could see it with a radio telescope such as MeerKAT. So this is a space laser on the size of galaxy. The term is mega maser.
So that was found like this, massive maser in space, and that was found as part of the Laduma project, which is one of the large surveys on the MeerKAT radio telescope, South Africa's big radio telescope. And we also heard from Associate Professor Sarah Blythe, who is one of the lead investigators. And the name Laduma, do you want to explain more about the meaning behind that?
Yes, it's got quite a few meanings. In fact, we were putting in the proposals around the time of the Soccer World Cup 2010. So Laduma was a really nice topical word at the time because Laduma means it thunders in Zulu, and it's also what people shout when a goal is scored in soccer. But in addition to that, because of the changing frequencies of the MeerKAT receiver, we end up looking at a shape in space that is like a vuvuzela, one of those trumpets that people like to blow at soccer matches in South Africa. And so it all fits together quite nicely, the Laduma, the vuvuzela, mapping out the space that we'll be looking at in our survey.
That's just one of loads of MeerKAT discoveries that we reported on this year. But actually, before we keep going with MeerKAT, that's not all that's happening in Sutherland, the new instrumentation at SALT. There's some other exciting stuff going on there.
Yeah, so I mentioned it a little bit earlier. The ATLAS telescope, the Asteroid Terrestrial Impact Last Alert System, which is a very, very cool name, we spoke about in episode 48. We actually spoke about it in our first episode too, but now it is fully functional. It was commissioned just before Christmas last year and immediately found a couple of near-Earth asteroids.
So since we've been commissioned 2 or 3 weeks ago, we've seen many asteroids, but all of them have been known ones, or someone has beat us to it and discovered them just before we saw them. But on Saturday night, we saw the first one where we were the first people to see it. So we've submitted that to the Minor Planet Center. A few minutes later, they said, hey, this is something that's not in the database. No one submitted this before. So by Sunday night, it was confirmed as 22 kb. So that's Atlas Sutherland's first asteroid discovery. Yeah.
And has continued to do so over the last few months, picking up various potentially hazardous objects and making some really cool discoveries. So it's operating really, really nicely, protecting us from asteroids coming in to hit the Earth. Nothing to worry about yet. You'll be the first to know if there is.
Will we?
Maybe you.
Me? Okay, great. I'll take it.
Let's just hammer together a quick podcast to let our listeners know. Hi, everyone. It's Dan and Jacinta. There's an asteroid coming. Bye.
Have fun with that. Bye. Well, speaking of crashing. No, that was a terrible segue. I apologize.
You've got to try that, don't you?
No, I'm going to double down. I'm going to keep going. We spoke about, in episode 46, a crash of clusters with Dr. Kenda Knowles, and she was telling us about another survey that was done with the MeerKAT telescope, this time of large clusters of galaxies. So groups of galaxies. We had a whole debate about collective nouns. I was aiming for a crash of clusters or a clash of clusters for like... what's a group of clusters, but I was quickly put in my spot and told that there is already an astronomical term for that, and that is a supercluster, noted, which I should have known because I have worked on superclusters before, so.
The debate rages on still.
Yes. Anyway, we're learning about clusters that are crashing into one another.
Yeah, but not just crashes. We also talked about some explosions. We had a conversation in episode 39 with Miriam Inyamai about erupting novae, which are stars which are, are erupting, and also fast radio bursts.
So I was working on radio observations of thermonuclear eruptions, to be specific. At the moment, we're closely following a nova, a recurrent nova, which is a white dwarf and a red giant that went into outburst again.
Ooh.
Yes, with meerkat. So that is very exciting. It went off 15 years ago.
So is it actually quite rare for us to see the same object go nova more than once?
Yes, I think it's rare.
So it went off again earlier this year, was it?
No, it went off on Sunday last week.
Whoa!
I mean, this Sunday.
What? Wow!
Yeah, so it went into an eruption this Sunday, and we got some meerkat observations. We have some results at the moment, and it's really exciting.
Oh, hot off the press! This is amazing!
It is.
We also spoke more about fast radio bursts with Marissa Gea in the following episode 40. She talked a lot about, what these things are, how we've discovered them over the last few decades, and why you should never open your microwave before the beeps.
Oh, yeah.
So if you want to hear more about that, go listen to episode 40.
Yeah, exactly. Both Miriam and Marissa were talking about FRBs, fast radio bursts, and how we just don't know what they are. There's some ideas, though. What do you call it? A megapulsar? No, a magnetar.
Yes. Yeah, so...
A pulsar.
Yeah, a highly magnetized, spinning old remnant of a star.
Neutron star,
yes,
yeah.
So we'll find out
Very cool
in
stuff.
the coming years, I have no doubt. In astronomy, we trust.
April this year, we had a signature coming from within our galaxy. And so for the first time, we had something that looked like a fast radio burst from a source in our galaxy.
Okay, give it to us straight. What's the source?
Okay, so the source is a galactic magnetar. It's basically just like the overly magnetized pulsar. So it's a neutron star, but it's a different neutron star in the sense that it's got a magnetic field that is, just so much more strong than what we have for a pulsar. So we're talking about something that's 10 million times brighter than what we've seen from this particular source before.
Right, I'm gonna attempt another tenuous
Segue.
okay?
Mm-hmm.
Yeah. All right, so magnetars, right, are a type of pulsar. And with pulsars, that's one of the challenges of what we're going to do at the SKA, try and use them to detect gravitational waves. Gravitational lensing, also part of Einstein's theories. In episode 43, we spoke with Tariq Blecher and Shilpa Ranchod about their work with gravitational lensing and trying to detect very faint hydrogen with that method. How was that, Dan?
If you followed that, ladies and gentlemen, congratulations to you. But yes, a very interesting work, and gravitational lensing is a very, very cool tool. Basically seeing how matter is lensing light or curving light from distant objects, and you can learn something about the mass of intervening objects, things like hidden hydrogen, which you can't see with your naked eye, but you can sort of weigh by using some gravitational lensing. A very nice tool which is used for various aspects.
Yeah, I mean, including magnifying light from behind the massive object, so trying to detect very, very faint hydrogen gas, which is further away than this massive object, but it gets magnified due to the lensing. So it's a very clever technique, very, very difficult. I don't think anyone's actually achieved it yet, but you got to be in it to win it, right?
I saw a very cool thing the other day that they spotted a galaxy, a lensed galaxy, so a galaxy sitting on the other side of a big cluster of galaxies. And a few years ago, they spotted the lensed version of it, which had the light had bent around the one side of it. And then just this last year, they spotted the same galaxy lensed at a different point. And they've managed...
Cool.
It gets cooler. And then they've managed to sort of work out the size and orientation of that cluster, and they're predicting in 2037 that they're going to see the same galaxy coming round the other side now.
No way!
I know, right?
Oh,
So cool.
that's awesome.
Something to look forward to.
Oh, yeah.
So from superclusters to supercomputers, we had a couple of episodes speaking about how astronomers do their work and the incredible machines we have to use. We spoke with Michelle Lochner in episode 38 about the rise of the machines and machine learning, how we are training computers to do a lot of the...
To come and kill us.
Yeah, well, ultimately. But in the meantime, if in the meantime, if they could do some of the astronomy for us, that would be super. Because as we all know, we're getting more and more data than we can humanly deal with. So the smarter we can make our machines, the easier that they can deal with that data, and the faster we can learn.
What does a machine learning algorithm do? It's a thing that takes inputs, does some stuff, and produces outputs. In the example of telling the difference between cats and dogs, the input would be an image, so some kind of picture, and the output would be cat or dog, right? So it's the prediction of what should this label be for this image. Okay, so the question is, what's all the bits in the middle? What's the stuff doing that goes from an image to cat or dog? The bit in the middle is the algorithm itself. A neural network will take an image and pass it through what's called a layer of neurons. So these are like neurons in the brain. And there can be many layers of neurons that are connected in some particular way.
Okay, but when we say neurons, it's not like an actual neuron in our brain. It's some piece of code, right?
It's a piece of code, yeah. You can think of it as these pieces of code that we use mathematics to connect to each other.
Yeah, and Michelle's using machine learning to try and kind of identify anomalies in the shapes of galaxies and objects in space. And so she's written a code and or a program, and she calls it the best name I've ever heard, which is astronomy.
It's very cool.
An astronomy anomaly. Try saying that fast several times.
Thank you for explaining it though, because I didn't get it.
Again, yeah. Just in case you didn't get it. Just from the name, and then the first time I explained it, I'll explain it again. You're welcome.
We also spoke to a couple of simulators. We spoke to Rob Yates in episode 41, and then Amima just in our last episode 57, about how astronomers use simulations to try and understand how galaxies are forming and evolving. And Amima spoke about dust and how that affects the evolution of galaxies. So some very cool conversations there, and a great complement to the observational astronomy.
So you basically study stardust, right? Or star smoke in a way.
Yes, it's stardust. And I always love the expression that says dust to dust, from dust to dust to dust to dust, which is like captioning it perfectly, because you start from a dying star and then the dust itself influences how the stars are formed. So it's kind of a loop.
Yeah, and I think Rob spoke about like the whole chemical enrichment process, how metals get formed and dust, and how that changes things, and how they form stars, and then how the stars explode and cause feedback into the rest of the galaxy. And yeah, it was the whole kind of picture. It's similar to what we spoke to Moses about in the previous season, observationally, like the life cycle of a galaxy, but kind of within a supercomputer. Yeah,
and trying to link those two so that the observations and the theory align.
Okay, so from... Oh. I've lost my confidence now. I'm just going to do it. Okay, from simulating the universe to our very real life down here on Earth. How was that one?
I think we should name this episode Segues.
Terrible segues.
Yeah, scientific segues.
Oh, I like the alliteration on that one. Okay, all right. Sorry, listeners, we're getting way off track. Anyway, we had a few down to earth episodes. For example, in episode 42, we spoke to Dr. Eugene Gorosh.
Yeah, I really enjoyed that episode. I spoke to Eugene, who is what was he? A geologist, not a geologist.
And a petrologist?
Yes, petrologist. I'd always wondered about. We hear about stars forming from gas and dust, and we were just speaking about galaxies and how they evolve, and then we know planets form around stars, But how do we get from that to this, like where we are and what we are? And it was just a fascinating conversation with Eugene about that. Definitely one of my favorite episodes, actually. How minerals form, why there's so many diamonds and where they are. and just like a nice little puzzle piece in between the planetary formation and then kind of the rocks and minerals and ultimately life we found on Earth.
Yeah, it's kind of like the final, what would you call it?
I just feel like it's
the final puzzle piece.
I don't know if it's the final. I think there's plenty still missing, but it's one of the ones which I'd kind of never really considered. You talk about the evolution of the Earth, or like the Earth formed from rocks around the star, they collated, like boom, yada yada yada, and then life. But like
fair enough. What's the bit in between?
The yada 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 that nobody's really spoken about before. Or I haven't read about. I think Eugene's spoken about it a lot, probably.
True, yes. And then in episode 51, we spoke with Professor Travis Rector, and we realised just how unique the Earth is. And the yada 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 is very important because of how unique it is. And he was telling us that there really is no planet B. There's no other exoplanets out there that we've found that could possibly sustain human life. Liquid water has never been found on any other planet except the Earth. And colonizing Mars is, unfortunately, sorry, billionaires, just not a thing that's really actually going to happen on any reasonable timescale. And so we have to look after our planet.
But astronomers offer a very important perspective about the issue of climate change. We understand the finiteness of the Earth. We understand that there's no place else we can go. I'm sorry to those billionaires who think we're going to colonize Mars. It's not going to happen. And we know about exoplanets, and we know really how special life is here on Earth, and that it really is truly the only place we can live. There really truly is no planet B. And that has become the mantra or the calling card for the climate change movement. What could be more astronomical than that?
Yeah, it was just interesting to bring that astronomy perspective on the fight against climate change.
Yeah, absolutely. And we also actually mentioned that with Phil Diamond when we were chatting about SKA, and we asked Phil what the SKA plans were in terms of sustainability. It's a massive telescope, it's a massive project, and there are some plans for SKA to be utilizing renewable energy resources to run the SKA, to minimize the impact we have as astronomers on the planet. What considerations are being taken with regard to the SKA in terms of climate and sort of environmental impact?
So as well as being good citizens locally, we need to be good citizens globally. And every aspect of what we've been trying to do in terms of designing the telescope, we've been looking at long-term sustainability. So the whole of the site, the SK Low site in Western Australia, will be powered by solar power with battery backup. And similarly in South Africa, we are connected to the grid, and we will be looking at making sure the power coming in is as green as it can be. But we're also putting solar PV stations in for some of the more remote dishes in the SK mid-array. And we're looking at a longer term future which might have solar PV for the whole of SK Mid.
Yeah, I think that's absolutely essential, because we as astronomers, as we spoke to Travis about, know exactly how unique the planet is, and so we have to walk the walk as well as talking the talk. And I also thought it was really awesome in episode 37 when Phil was talking about the importance of projects like the SKA for global collaboration, so kind of bringing the people of the world together as well, uniting us to achieve something really positive, to achieve a mega science project.
Something like the SKA, do you see it as a sort of vessel of peace or some way to bring countries together?
I do. I honestly do. What it does is it brings a diverse range of countries, government officials from those countries, scientists from the countries. They sit around the table and they solve problems jointly. They work together. We have to have dishes built in one country, integrate with software developed elsewhere, and receivers from another country. And the whole package has to work seamlessly. So we're working on a very detailed level with scientists and engineers and companies in those different countries. And then on a governance level, all of the countries, once they are members, they get an equal voice in how all of this happens.
So I really liked that kind of people aspect of astronomy because you don't often hear about it. We're talking about things that are extremely remote, and this was sort of really bringing it back home. And so we had a couple of other episodes on that theme of people, which essentially is what science is, as you were saying earlier. You know, science is actually the scientists. It's about people, and we don't often talk about that. But in episode 54, we spoke to the board of the African Network for Women in Astronomy. That was Professor Mirjana Povic, Vanessa McBride, Priscilla Mulhechi, and Carolina Odman. And they were kind of telling us about their enormous efforts to try and create a community of the female astronomers on the continent, and how important that is to bring us all together and to help one another progress in our careers. And yeah, I thought that was really lovely.
Yeah, I think so.
Good for your mental health.
Absolutely. It's just wonderful to acknowledge and consider these other aspects of astronomy and of society and what we can do to try and help other people who maybe don't have all of the advantages or opportunities that you or I do, and how we can sort of grow the astronomical community in an equitable way, I suppose, that everyone gets the opportunity to succeed. But speaking of mental health, we also had a wonderful conversation with Jack Radcliffe, Dr. Jack Radcliffe from the University of Pretoria, where we focused exclusively on mental health almost. We did speak a little bit about Jack's work in episode 52, but then spoke a little bit about all of our experiences, both Jack's and also mine and Jacinta's, and the important role, it plays not just in your work and astronomy, but in your life, and how important it is to actually just look after yourself so that you can succeed and just
function.
Yeah.
Yeah, so look after your minds, everyone, because it's your most precious asset, really. It's what we all need to do whatever jobs we have, and also to just live our lives. So look after yourselves.
Yeah, and if you didn't catch that episode, I really do encourage you to go back to episode 52 and give it a listen. Or give it a re-listen.
Yeah. So yeah, thank you so much to all of our guests from this season. Obviously, without you, we don't have a podcast. So thank you so much for spending the time to speak with us. And also, without our listeners, we don't have a podcast. So this is all for you. So thank you for joining us and for sticking with us. And we hope you'll come back and join us again when we start season 5. And I suppose we don't have a podcast without ourselves. Can we thank ourselves?
Oh, thank you, Jacinta.
Thank you, Dan.
Yeah, I think I'm really proud of what we've achieved. I think that, it started off as a dream, and we built it up from nothing, and I think it's been very successful. So
yeah,
I hope that the listeners feel that too, and I hope they've really enjoyed the journey thus far. And we do intend to carry on, but we do intend to take a bit of a break.
Yes, for aforementioned mental health, which is very important, everyone. Can't help anybody else if you don't help yourself first. Speaking of help, we started off with the Cosmic Savannah doing everything ourselves, all of the editing, all of the social media, absolutely everything. And now we thankfully have some help with that. So thank you again to our audio editor, Jacob Fine. Thank you to Sue Marie Hatting, who has voluntarily done a whole bunch of social media. If you follow us on any of our Instagram, Facebook, or Twitter accounts, you'll see the beautiful posts that Sue Marie does every time we have a new episode. I don't know how she does it, so thank you, Sue Marie, for doing social media magic. And we have our transcribers who transcribe every single episode into English, and that's Justine Crook-Manzur, Moloko Makweja, Mohammed Omar, and Vuyo Mpechwa. And that work is really important because we want to make sure that we're accessible to those who are hard of hearing or those who might want to read along, especially if English is not your first language. And also we use those transcriptions, export them as subtitles, and we upload them to our YouTube channel as audio-only episodes, so you can have some subtitles so that if you don't speak English, you can actually change the language so that we have accurate subtitles. You can change it to, I suppose, as accurate as possible in different languages, and that might help others, help us to be a bit more inclusive. So if you know anyone who might like to access this podcast in any of those other methods, do let them know that that's an option.
Yeah, and at the risk of stealing all of the thunder from the credits, also just thanks to those who've made the website, the artwork, and the podcast possible. Mark Allnut, who did our music production, which we absolutely love still. Michal Werchek, who... It's kind of better how he did it, but no.
I don't know what you're talking about.
Michal Werchek, who did a lot of our photography, which we use, although we should probably get some updated photography with my new grey hair. And
all right, Michal, for next season, if you're listening.
And then, Carl Jones, who I had a wonderful time with up in the Kgalagadi, taking the photos for our new artwork, which was designed by Susie Karras. And, I think we needed a bit of an update to the logo, and I absolutely love it. So thank you to them for making that possible. And then also just to our funders and those who make the podcast possible, the South African National Research Foundation, through which the South African Agency for Science and Technology Advancement works, and they have supported us, as well as the South African Astronomical Observatory, which continues to support us in various aspects. Then finally, the University of Cape Town Astronomy Department. So thank you to them for believing in us and supporting us. And it's not the end. We're talking like it's the end, but we are just going to take a little bit of a break, maybe join you again in the new year. And Jacinta, what are you up to over this break? What are your plans?
Well, yeah, so I guess we expect it to be quite a long break. So in some ways we're saying goodbye for now, but not forever. So I've already taken up my new position at UCT as a lecturer. So I will be doing my first course, which will be third year extragalactic astrophysics. So I will be lecturing that course, which I think the first time you lecture a new course is apparently a lot of work, because I have to make all of the lectures and all of the assignments and learn how to lecture and, the usual build a plane while it's already taking off kind of thing. But that'll be fun. I've got a new little research group. I've got an honours student and I've got a PhD student. And so we'll be working on some hopefully exciting science. And yeah, so busy. How about you, Dan?
My travel's kicked off again, so I'll be flying to Spain next week for a conference in Europe. And then we'll be back for a couple of weeks before I head to South Korea for the International Astronomical Union's General Assembly, which will be held in Busan. And we will be representing SALT, the Observatory SAO, and the General Assembly 2024, which will be held in South Africa. So we'll be promoting that and trying to encourage astronomers from around the world to join us in 2024 here in Cape Town. And, have another sort of wonderful event down here. So I think that it's not going to be a hard sell getting people to come to South Africa, but we should have a lot of fun in South Korea promoting that.
Yeah, have an amazing time.
Thank you. Yeah, so I think I'm looking forward to it. Looking forward to going to South Korea too.
Yeah, it's fine. I'm not jealous at all. It's cool.
You'll be lecturing. You'll be having
Yay.
a ball. Also planning to take a little bit of leave. I've got a couple of nice trips planned into the bush, so looking forward to those. And yeah, we'll be back
at some point.
Astronomically, there's a couple of events coming up too, are there not? I gather there's a solar eclipse coming.
There sure is. There's a total solar eclipse coming to Australia, but it's only going to hit the tip of a place called Exmouth in Western Australia. That'll be happening on the 20th of April 2023. I'm really hoping to be here for it. Fingers crossed that the timing works out. I've never seen a total solar eclipse, and I would love to experience that. Apparently it's like life-changing.
It's pretty cool. I'm pretty happy to say.
Wait,
that I have
you seen that?
One.
I think we've talked about it before, but I forgot.
2002. I went up actually to the Kruger Park, where you have been, and yeah, it was spectacular. Well, I mean, we went up and we were inside the park, and it was a bit cloudy, so there was sort of cloud on and off. I didn't get to see the sun or the going into eclipse, but once it was total, the clouds did clear a little bit, and we watched it come out. And yeah, just an amazing experience being in the middle of the park, away from anything or anyone, and hearing the birds going to bed and waking up again a few minutes later. It was just a really, really special experience, and I hope you get to experience it. But if not, then there will be more and more opportunities over the coming years. I know there's an excellent one in 2030 in South Africa, which I've already booked my accommodation for.
You've already booked your accommodation. I remember that. What year is that?
2030.
Oh, right. Cool.
I have some time.
Anything else going to happen in the next year or so?
Well, we did mention the JWST images coming out, which is really, really exciting.
Yep.
But other than that, I don't think anything jumps to mind immediately. We don't have any more eclipses here in South Africa. And yeah.
Yeah, hopefully the SKA groundbreaking and maybe even Jacinta coming back to South Africa.
Which will also be groundbreaking.
So anyway, before we end, we better stick with our tradition. How are you, Dan?
I'm well, thank you. Selfishly looking forward to a little bit of a break from the podcast. Apologies, but it is a bit of hard work. Really looking forward to my travel. It's been a couple of years now since I've gone anywhere. It is really nice just going to a new country, meeting some astronomers from other parts of the world and doing some networking. So really looking forward to that. And yeah, otherwise just feeling pretty good. Not too overwhelmed with work at the moment, which is really nice. And, trying to slowly tick over and get things done without stressing myself out too much. How are you?
Yeah, I'm pretty good. I am about to apply for my visa, so I have to travel over to the east coast of Australia to do that. So I have all of my documents finally, and I will be applying for the visa. So please keep your fingers crossed for me, or hold your thumbs, or whatever your saying is, that I can get my visa soon, so that I have at least the freedom to choose what country I will be in, and the freedom to come back and hopefully be there for the start of semester 2 so that I can actually lecture to my students in person, which would be really nice. Yeah, so that's what I'm up to at the moment, and I'm going to catch up with some friends over, friends and family on the East Coast as well, so that's also going to be a nice
Great, well, good luck. I'll be holding thumbs.
Thank you. Well, I think we should do our usual credits, just because in case we need to have a blooper at the end. How are we going to have a blooper if we don't have credits? Ending credits.
Well, I think you messed up the opening credits, so we've got one already. But
well, don't tell them. What if we weren't going to use it?
Okay, well, there might have been a worse one, which has been eliminated, and you didn't notice, listeners, but it's coming.
Oh. All right.
So that is it for today.
Okay, we're gonna do this. Okay, all right. Go ahead. Start again.
We'll do it. We'll do our credits.
Okay.
So that is it for the day, and that is it for the season. Thank you so much for joining us. Thank you for supporting us, for following us, for liking and subscribing, rating and reviewing. We really appreciate it all. And, every download and every listen warms our hearts. So thank you, thank you, thank you. And we hope you'll join us again for the next episode and the next season of the Cosmic Savannah.
In the meantime, you can visit our website, thecosmicsavannah.com, where we have the transcript, links, pictures, and other stuff related to all of our episodes from the season.
Yeah, as well as all of our episodes of all time. So you've got 57 episodes to catch up on, as well as some mini episodes from the students from our boot camp. But also, continue to follow us on Twitter, Facebook, and Instagram at Cosmic Savannah. That's Savannah, spelled Savannah. You can find us on YouTube, where audio-only episodes are uploaded with closed captions, which can be auto-translated into many different languages, including Afrikaans, isiXhosa, and isiZulu. Thank you to our social media manager, Sumri Hatting, and our audio editor, Jacob Fine.
Also to Mark Allnut for music production, Michal Werchek for photography, Carl Jones for astrophotography, Susie Karras for graphic design, and Justine Crook-Manzour and Moloko Makweja for transcription.
As mentioned, we gratefully acknowledge support from the South African National Research Foundation, the South African Agency for Science and Technology Advancement, the South African Astronomical Observatory, and the University of Cape Town Astronomy Department.
You can subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. And we'd really appreciate it if you could rate and review us and recommend us to a friend.
And we will speak to you next time on the Cosmic Savannah.
Bye.
Bye. Welcome to the Cosmic Savannah with Dr. Daniel Kahneman.
And Dr. Jacinta Delhaize.
Yeah. And then.
Okay. Maybe we start again.
58 episodes.
Yeah.
In?
I still can't remember the line.
Still haven't got the. Yeah.